Example number 4, Todd Hall has $5,000 to invest and will commit the whole amount for 6 months to one of 3 technology stocks. A number of uncertainties could affect the prices of these stocks, but Todd is confident, based on his research, that one of only several profit scenarios will prove true of each one at the end of the 6-month period. His complete analysis is shown below. Find the expected profit or loss for each of the 3 stocks and select Todd's optimum choice based on these calculations. For company ABC, the expected profit or loss is equal to negative 400 times 0.2 plus 800 times 0.5 plus 1500 times 0.3. When we put that into our calculator, we end up with an expected value of 770. He is expected to have a profit of $770. Company RST has an expected value of $500 times 0.8 plus $1,000 times 0.2. The expected value, therefore, is 600. And for company XYZ, expected value will be 0 times 0.4 plus 700 times 0.3 plus 1200 times 0.1 plus 2000 times 0.2, and the expected value is 730. Looking at this, it looks like company ABC has the highest expected profit. When we look at the expected value for the binomial distribution, there's not much difference that is taking place. We're going to look at an example here. We are going to look at an example here. Suppose there is an island that gets rain on 40% of the days. If you randomly select 5 days, what is the expected number of days it rained? We will use the problems below to determine this. I went ahead and I answered all of the binomial probability values for each of these. It's just substituting into the equation like we did in section 12.4. And I didn't want to take up a bunch of time to do it. But we're going to focus on the expected value part of this, which is down here. It says use the given information to find each of the following expected values. And remember that expected value is the sum of your x times your probability of x values. Well, our probability of x for 0 days of rain, we found up here is 0.07776. And for 1 day is 0.2592. For 2, 0.3456. For 3 is 0.2304. 4, 0.0768. And for 5 is 0.01024. I just took the values that I had already found for us from up here and added them to the table. Then all we need to do to find our expected value is multiply and add everything together. 0 times anything is 0. I'm going to just write 0 for the first one. And then 1 times 0.2592 plus 2 times 0.3456, 3 times 0.2304, 4 times 0.0768, and 5 times 0.01024. I will use my calculator and calculate all of these things out. I end up with 0 plus 0.2592 plus 0.06912 plus 0.06912 plus 0.3072 plus 0.0512, and the sum ends up being 2. The expected number of days that it will rain is 2 days. Now, we could have taken a shortcut. We don't need to go through the whole process of using the binomial formula and then getting our table and finding this. If we know that we have a binomial distribution, our expected value is going to be n times p. In this case, our n was 5 days. And our p was our probability of success was 0.40 or 40%. 5 times 0.40 is 2. So I wanted to go through the process of showing you that from a binomial distribution, this is where these items come from, but we can use the shortcut and make our lives easier. Our next example down here, your teacher uses a weighted average to calculate your grade. The weights are 55% for tests, 25% for the final, 15% for quizzes, and 5% for homework. If you have an 86 average on tests, a 92 average on quizzes, and 100 on homework, what grade do you need on the final to have a weighted average of 90%? Again, we can use this idea of expected value to help us solve this. And our weights are going to be our probability. We have an average of 86 on tests, 92 on quizzes, 100 on homework, and we want to know what we have to find on the final. The weight of our tests is 0.55. That's the probability. The weight of quizzes is 0.15. The weight of homework is 0.05. And the weight of the final is 0.25. We want our expected value to be 90. Since we want our expected value to be 90, we will say that 90 is equal to 86 times 0.55 plus 92 times 0.15 plus 100 times 0.05 plus x times 0.25. And then all we have to do is solve, move everything to the left-hand side, and divide by 0.25. When I multiply, I end up with 47.3 plus 13.8 plus 5 plus 0.25x. I'm going to combine my like terms here. When I add 47.3, 13.8, and 5, I get 66.1. I'm going to then subtract 66.1 from both sides. I have 23.9 is equal to 0.25x. And I divide by 0.25 to find out that x is equal to 95.6. You need to get a 95.6 to get an average of 90%. Our last question here. Our last question here says to find the expected value for a binomial distribution in which n is equal to 18 and p is equal to 0.62. Our expected value, since this is binomial, is n times p. Therefore, our expected value will be 18 times 0.62, and 18 times 0.62 equals 11.16. And that's it for chapter 12.